This conference will now be recorded.
Hi, good morning, everyone. I think in the last session we have discussed about different types of uh, volume claim reclaim policies actually. So we have discussed about delete, recreate, and recycle. Okay, so we have seen with examples as well what it does exactly. So the default reclaim policy for your PV is nothing but it is written. Okay, if you don't specify anything, and if you try to write a YAML file for creating a PV, by default it will use a reclaim policy called written. So you know what is a written? Written in the sense once a PV was bonded to any one of the PVC, and after that it was your PVC got deleted, then your PV will go into a released state. Okay, so released state in the sense earlier it was attached to some particular PVC, and now that got removed from there. Okay, detached from that particular PVC. So that is a point of released status. Okay, so that particular release status, which means that again you cannot reuse that particular PV to any other PVC. Why? Because your PV and PVC is one-to-one mapping. Okay, so you cannot reuse the same PV for another PVC, and that too it is not in available status, right? So that's one more thing which we have to remember. So that particular PV, in order to overcome that particular situations, we have edited that particular PV specifications called claim reference. When we created, right, PV, if you want to remove that particular bound information, which is present even after the PVC got deleted, because of that which is going to a released state, I remove that particular claim reference section, and after that again it will be available, and now one more PVC can get attached to that particular PV. So this is the manual steps and practical things which we have seen actually. Okay, after that we have seen another reclaim policy which is called as recycle. So recycle reclaim policy, what we have seen when we use NFS as a backend, so whatever the files which you create and get attached to your container, okay, using this NFS PV. So what is happening when you delete your PVC? Okay, the data which is utilized by your PV is getting removed. So it will clean up all the data on your backend storage, and it will make your PV available like a new disk or a new volume. Okay, so that is how it is made your PV as available states automatically. That is a reclaim recycle policy. Simple recycle policy in the sense it will clean up all the data what is present in the backend. Let us say if it is NFS, or if it is AWS EBS or any other thing. Okay, and but as of now, this recycle policy is available only for NFS and host path. That is what we have seen in the documentation earlier. And after that, we have seen a delete reclaim policy, which is nothing but if you delete your PVC, PV also will get deleted, and the backend storage also will get deleted. And these are supported only for few types of backend storages like AWS EBS, Azure Disk, okay, Cinder. Okay, there are few things only which are supported for backend delete reclaim policy. Okay, so we have to always look into that particular limitation. Okay, it is recommended to search in the documentation, the official document. So it is always recommended to scroll down and go to the section called retain, delete, and reclaim policy. Okay, so which you have to read about this particular three types of policies. And after that, if you scroll down a bit, that is here below this. Okay, so below this, you can see here what is retain policy, what is recycle, what is delete, and who are supported with this. Currently, only NFS and hostpath is supported recycling. Okay, AWS EBS, CSE Jet, Cinder disk, and Cinder volumes support deletion. Okay, this point you have to remember always. Okay. Now, now let us try to understand access modes. Okay, so access mode in the sense what? Okay, the persistent volume can be mounted to a on a host. Okay, in any way supported by the resource provider. Okay, it depends upon the resource provider as well. Like you can attach your volume to your ports. Okay, on that specific node. Now we have seen that when I'm trying to use a host path, I am specifying only read write once. Okay, but when I'm using NFS, I can provide either a read write many. Generally, when with my examples, I specified read write many. We can also specify read only many. We can also specify read write ones also. Okay, that is also possible. Three access modes are possible. With your host path, this particular access mode is not possible. In NFS, is it possible with this particular option? No, it is not possible. The new option which we got, right, it is under development stage. So let us not think too much about this. Okay, so read write once pod in the sense only one particular pod can attach that particular volume. Okay, that is called as read write once pod. It is under development, so in maybe at the end of the course, or I will try to do this. Why? Because it depends upon the plugin what we are using. Okay, it depends upon the CSI driver. Okay, so that's a reason we have to look at. For other things, you can say it is not supported. For NFS or host path, nothing is provided as of now. Okay, so let's investigate later. But our concentration is much on this particular three options right now. Okay, so here let's go. What is read write once? So read write once in the sense it is written like RWO. RWO in the sense read write once. What does it mean exactly? Technically, for a person who is new to this particular environment, how he can understand what is read write once? So read write once in the sense a volume which is created on the node can be used only by that particular pods running on that particular node. Okay, if a pod is running on a different node and wants to use a volume which is created on another node, it is not possible. That is called as read write once. Volume can be mounted as read write by a single node. That's it. Only single node can do it. For example, take the host path, which we can do only read write once. Where is the host path example? Here you can see, right? What is this column? Tick mark in the sense this is possible. Okay, read write once is possible. Other things are, it is showing you blank in the sense it is not, you cannot use this options. Okay, you cannot use this access mode or you cannot use this access mode. Okay, so what does it mean host path in the sense, let's say you created a PV with host path. Okay, so when you try to create a PV with a host path, after that you will try to create a pod. Okay, if the pods are distributed on multiple nodes, let's say one pod is running on one node, other two pods are running on another node, let's say A, B, C. Let me draw a diagram that makes some sense. Let's say this is your cluster. For example, let's say, sorry, this is your one node, this is another node, and this is another node. Okay, so these are the three nodes. Now let's say you created some particular PVC anyway you will try to create, but for example I'm saying PV with the backend type code. Okay, it is host path. It is using host path. Okay, now whenever you create a PV, it doesn't mean that it will go and create your PV on a specific node, right? It is just a metadata information as of now. When it will go and create that particular path on that particular node, in the sense it decides once your pod has been created. Okay, when your workload, okay, decided has been created, or if your standalone pod is created, then this particular path, host path, what you specified, that will be created on that particular specific node where your pod is running. Okay. Now let's say you are creating some particular deployment. Let's say your deployment is specified with a replica called 3. Okay. So two pods are running here. This is one pod and this is another pod, and one pod is running on this particular node, for example. Okay. So this is like pod 1, for example, and this is pod 2, and this is pod 3. Okay, done. Once this decision has been made, okay, so this host path, what is specified in the PV, that will get created here. For example, let's say /var /backup, for example. Okay, so on this particular node also, this particular pod is running, same pod. Okay, means same pod in the sense same template pod. Okay, so it will also create this particular var/backup. Okay, so now you might think that in the access mode, when you specify read write once, in the sense the path, host path, what is created on this particular node will be utilized only by this particular pod and this particular pod. Okay, this particular pod which is running on this node cannot utilize this particular volume. That is the meaning of read write once. Okay, so read write once in the sense the volume which is attached can be mounted as read write by a single node. That is the meaning of it. Read only many, in the sense the volume can be mounted read only by many nodes, which means that now this is not needed. Let's say if you are taking NFS, how many nodes it is running, it doesn't care about it. Ultimately your backend is stored in NFS server. Okay, so that can be multiplied. Okay, you can here you'll attach one particular directory to the NFS, one directory to the NFS, and one directory to the NFS. What is the directory? Whatever the pod has been created, that pod directory will be there, right? /var lib kubelet /pods / that particular pod id /volumes. That directory will get attached to the NFS volume. Okay, so this is how it is. This is how it is created as read only many or read write many. Read only in the sense only read action you can do it. If you're trying to write something on that particular path on the backend storage, it doesn't allow you. That is called as read only many. Who cannot write the data? The container. Okay, so read write many in the sense you can do the read operations, and you can also write some data into that particular volume, backend volume. That is called as read write many. Okay, so that is a major difference between this particular access mode. Always keep in mind to read this particular table. Okay, at any point of time this particular options might change, but most of the cases only file system type of storages will allow all the three operations, like NFS, network file system, Azure file system, okay, and Ceph file system, okay, and we have something like Gluster file system, okay, and then we have Kubebyte, and then we have NFS, which I've already told you. Okay, so this is how it is. Only this option, Azure file 2, and this one 3, depends, right? 3, and this one 4, 5, and 6. Only these 6 are available for us with all the 3 options which we can be specified, but it depends upon what type of application you are trying to deploy. That also makes points into criteria actually. Okay, but first of all you have to understand what is this access mode does, and then you have to specify accordingly to your PV and PVC. Your access mode for PV and PVC should be matched, then only those will get attached actually. If you try to specify your PV with a different read write different access mode, and in your PVC you are specifying a different access mode, even though all other parameters are equal, it doesn't attach. Okay, so that's how it is. So we have to be careful with that particular access mode parameters which you specify. Okay, even the storage also, if you specify something, but it will adjust that particular storage capacity what you specified in the PVC to the PV what we have, because it is one-to-one mapping. you cannot attach the same PV to another PVC. That since it is one-to-one mapping, there is no point for a PVC to be specified with a different size, right? You have to specify what size is present in the PV. Okay, that's how it is. So this is all about your access mode and volume modes and your access modes. Okay, which is important for us to understand. Okay, so yeah, so coming to the next point, let us try to understand something related to, I think we have completed this particular static PV creation. So let us try to understand what is dynamic PV creation. So dynamic PV creation in the sense, if you recall, when I'm trying to create a PV, I'm specifying some name to this particular PV so that my PVC can identify this particular PV with that particular name, right? That is called as storage class, right? That is a name which I'm trying to specify. Okay, let's say some local or some particular thing. Okay, if you see this example, you can see here, right? This is NFS example. You can see here the name what I specified in my PV. I am trying to use the same name to get attach this particular PVC to that particular PV. Okay, so that is a actual purpose of using this particular storage class name as of now. Storage class name actually. Okay, I think I specified only storage class name. Okay, this is fine. This is for static PV creation and all. What about dynamic PV creation? So dynamic PV creation in the sense, how many times and how many times I will come to know that as an administrator, but these many PV should be created for my applications. My applications can increase at any point of time. Okay, let's say today I'm using two replicas, tomorrow three replicas, tomorrow I want to increase it to five, or let's say I want to increase it to two, decrease it to two. At any point of time, I will scale in and scale out. Okay, when I'm doing that, as an administrator, how I will get notification for that? Someone has to inform me, or I have to observe that, and I have to do the necessary changes according to the extra PVs. What is left, I have to remove, or else I have to create a new PV for a new application to scale it. Okay, so always I cannot make these many PVs to be created, though the applications are not running with that number of utilized PV. So I cannot do that, right? Unnecessarily, I'm wasting my resource consumption, or let's say unnecessarily, I'm creating some PV which are not at all utilized. Okay, underutilized actually. Overutilized, let's say I don't have sufficient amount of PV for my applications what they are running. For that reason, they are in the pending state or something actually. So all this headache taking as an administrator, it is really critical for me to mm, observe this particular statuses actually. Okay, so to avoid this, we can create a storage class. Okay, we can create a storage class. Let's say, so we will create some storage class. So this particular storage class, when a PVC request comes to this particular storage class, let's say you will specify in your PVC file, PVC YAML file, what is the storage class name. Okay, if that name is matching to this, let's say NFS storage, for example. Okay, this is the name of my storage class. Now, when I'm specifying my PVC, I'll specify that this is the storage class. Or if you don't specify anything, let's say this is the default storage class. Okay, let's say this is a default storage class. Let's say you are trying to create some particular PVC. That PVC you have mentioned some particular name which is matching to this particular storage class, or let's say you forgot about writing the storage class name because you don't have the backend view of this particular data. You don't know what is the storage class. But if a person doesn't specify any storage class name, it has to come to this particular default storage class. That is my intention as an administrator. Okay. Now this particular storage class will create a PV based on the request. Okay. So based on the request, a PV will get created automatically. Okay, who will create this for you? The storage class will create it for you. Why? Because you specified the name of this particular storage class, right? Automatically it will try to create for you. Okay, now What it does, it will try to create a PV. So this will try to create a PV, dynamic PV. So dynamic PV, in the sense, it will generate with some random number. Let's say default hyphen PVC hyphen some random number actually. Okay, I will show you practically now, but that's how it will get created. Okay, just a second. I want to put this. Okay, with some random number it will generate. Now once this particular dynamic PV was created, your PVC will get attached to this particular PV. So as an administrator, now I don't need to take any headache of creating this particular PV whenever there is a new request, or whenever the destroy is happening on that particular pod. Automatically my PV also will get cleaned up. Okay, when you delete your PVC, automatically my PV also will get cleaned up. I will specify default policy, a reclaim policy as delete or something, so that that will also get deleted. Okay, so creation, at least it is happening dynamically, which means that I don't need to interrupt in middle and try to create a PV for that particular application. Automatically, if your name, the storage class name in your PVC is matching to my particular PV storage class name, that's enough. Or if you don't specify anything also, automatically this particular default storage class will be picked by your PVC. Okay, to create a request. Okay, once a request was created, automatically dynamically this particular PV will get created, and that will get attached to your PVC. To happen this, there are few things actually. Some things will happen. Let's say if you are using some Azure Disk or something like that, it will happen. Okay, but when you are using some third party tools like NFS and all, first of all you have to deploy the NFS server as a dynamic storage creation, and then you have to specify that particular paths and all to the storage class. Automatically it will send a request and it will create it for you. Okay, so to happen this particular process of dynamic storage creation, PV creation, to create this particular NFS storage class, default storage class, first of all you have to deploy your NFS server for a dynamic storage creation. So that is called as provisioner. Okay, so to deploy that particular NFS provisioner, we already have this particular documentation. Let me show you that. What happened? This is Ceph. Uh, Local storage. Let me show you that example actually. Whatever we have discussed about volume status, access modes, and everything is written here. Okay, so this is fine. Where is my example for? This is for NFS installation. You already know how to install NFS server. I think we have already created it actually. Okay, so don't need to worry too much about it. Let me check cross check once. So keep the clear get sorry NFS. Yeah. So it's fine. You can also verify it like this actually. It's running and everything seems to be fine. Okay. Done. Now what I need to do, I need to create a provisioner. So this provisioner, actually I created a separate document. This provisioner. Somewhere I pushed it actually. Just a why is this Ceph provisioner? This is related to Ceph NFS provisioner. Okay, you can see here actually. Okay, under provisioners only, you can open this particular NFS provisioner.yaml. Okay, so to happen this, actually we have to create this one. Here you can see the feature gate remove self link is equal to false. Okay, so this is what I need to specify, and then I have to create it. Okay, so what I need to do, from for 1.20 cluster, we see issue in creating a PV dynamically with NFS provisioner. To fix the issue, this is what we have to enable. So how to enable this particular argument? Anything, if you want to enable a feature or if you want to disable the feature, what I've told you, you have to open the manifest of your API server YAML file, and then you have to enable that particular parameter. So API server will get recreated with the new changes what you have done. Okay, whether it is enable or disable. Okay, now I need to search for my manifest file. So where is your Kubernetes related manifest files? /etc Kubernetes manifest API kube API server. Multiple times you will be working with this file in the examination. Okay, so get habituated to this. So in this I need to enable some particular parameter. So copy from here, because I have already written that hyphen symbol. Copy and then paste it here. Okay, done. Once you save this and come out, see what happens. If you try to execute some particular command, it is not responding. Why? Because your API server has been removed and it will recreate with the new pod and with the new changes. Let's wait for few minutes. Yeah, done. So it is successful after with the new changes. To see that, detail get pod hyphen n q hyphen system. You can see here 13 seconds ago. Every other pod is running with from past 7 days, but only this particular pod has been running from 13 seconds just now. Why? Because I have did some changes, it got recreated. Okay, this is the meaning which you have to understand. So okay, this parameter is enabled so that I don't get any issues in the backend. So now you are trying to create this particular storage class. You can see here. Now, as of now, do I have any storage classes? Let's see. Sorry. You don't have any resources as of now. Okay. Now, this is the storage class which I'm trying to create. This is the name of my storage class. So everybody, if they want to use this particular storage class, they have to mention this particular name. Okay, that is the point we have to remember. Annotation is nothing but a kind of label, but it also be helpful for to decide to enable some parameter. It's a not only metadata information, but also applications will use this particular metadata information to enable some feature or disable it, or if you to take some data, and everything will be utilized by your applications on this particular annotation as well. Okay, so in this annotation, we are saying that this particular storage class is a default storage class. Is default class true? Which means that now this storage class will be a default actually. I'll show you how it looks. And provisioner, in the sense, this particular storage class is using this particular provisioner in order to create a backend storage for a PV. Okay, persistent volume. Parameters RQ on delete is false. So what is your provisioner? This is your provisional data till here actually, till here. Okay, so you can see here, this is the image which we are using. Okay, and this is the NFS server details you have to specify in the environment variables so that your application, provisional application will use that, which means that it will contact to that particular NFS server. Okay, so this is what we have to do some changes. So take it up this, copy from here. Okay, let me scroll up, copy from here. Okay, first let me try to instead of creating the storage class first, I will try to create this provisioner first. Till here, right? So let's copy and create. Let me try to create under PV. Okay, NFS provisioner. Okay, dot YAML. So let's create this. So what is my NFS server? It's running on 128.0.2, right? So what directory I specified earlier? Let me see. Mm, export fs. You all know that I'm using my master node as um, server. Okay. So one is where NFS backup and where NFS as well. Both can be utilized. Okay. So done. Any one of them I can use. Let me try to remove this particular file now. Done. Now this is fine. RNFS is also fine. Is it backup or backups? Backup. Okay. Here also backup. Sorry. Backup. Backup. So IP address is fine here. I have to change here. Fine. Now for this particular provisioner application which I'm trying to deploy as a deployment with replica 1. Okay. So this is like a provisioner. So it will talk to the NFS server in the backend. Okay. And your storage class will take help of this particular provisioner to talk to that particular NFS server in the backend. Okay. So you can see here ksudhirdemo.com/nfs. This is the name which I gave. This same name you have to specify in your storage class section. Actually, where is that my storage class? Let me show you. So here you can see, right, ksudhirdemo.com/nfs. So you're telling to your storage class that try to talk to this particular provisioner, and the name you have to get matched. Okay, so don't forget about this. Whatever the name you specify in this particular thing, you have to specify the same name in the storage class to get provision. Okay, now let's close this and save it and come out here. So it's created, means it created some service account, cluster role binding, role binding, which we don't know actually. Okay, since we haven't completed authentication and authorization. So that is also getting created. Why? Because your provisioner has to talk to API and it has to fetch some information. So in order to talk your application talk to that particular API server, it needs authentication and authorization. That authentication is provided by service account. Authorization is provided by your this particular 4 options. Okay, so when I teach about this particular option, you will understand about it. Okay, so why? Because this application needs to or wants to talk to that particular Cube API server. Okay, to fetch some information actually. Yeah. So this is created successfully. Let's verify. Kubectl get all written over. It is created in default namespace. You can see it's running fine. Now let's try to create the storage class. Okay, storage class dot YAML. Let's try to create that now. So we have already discussed about this YAML right now, these entries as well. So let's try to create directly. And this is the default storage class. Okay. Now if you verify kubectl get storage class, you can see shortcut name is SC. This is in the brackets. If you see something like this, it is a default storage class. Okay. So this is how it is. And this is the provisioner, and the reclaim policy by default it is delete. Okay, so volume binding mode is immediate in the sense whenever there is a PV and PVC available, automatically it will get attached. Okay, allow volume expansion. Right now you cannot expand your volume, but even we can expand the volumes as well. Okay, So let's try to create a PV or not. We should not create a PV right now. That is our intention. Okay. So let's go back. So let us try to deploy some sample application which I've attached in the same documentation itself instead of searching for someone. Okay. So here we have done three things. Let me copy paste this and let me show you. You know about services, right? So let's copy this and then services, or we'll take this example in the same itself. MySQL hyphen
Uh,
provisions that I can
Sudhir,
understand. Yeah.
yeah, sorry, I got confused a little bit. So
Yeah.
we have process PV, PBC, storage class. Okay, before going into this application, can you just tell me how it is all connected? Uh, so PV is
First,
always connected to
yeah,
the
PV should be
okay,
created first. If your PVC should be utilized, if your application, see, my application is sending a request through with the help of PVC. Okay. And PV is the actual
okay,
component who will try to communicate to the backend storage. Okay. This is
okay,
the first picture actually.
yes,
And in order
yeah,
to send a request to that particular PV, it should get bound. Means in order to utilize that particular backend storage for your friend application, this particular PVC should get attached to that particular PV, that is called as bound. Okay, this is the next phase.
mm,
In this attachment and handling this particular bound, there are multiple ways, access modes and reclaim policy. It all depends upon them actually. So that is what we have
oh,
discussed. Now, as an
mm,
administrator, I don't want a headache of creating this particular PV. Why? Because I never
okay,
know or never I can control this particular PV creation at any point of time. Okay. 24 by 7, I
mm,
cannot look into this particular operations and see like how many applications are getting deployed. I need to create a PV immediately, or I have to delete it unnecessarily. It is running it. I cannot keep on doing this particular job, right? So as an administrator, I
yeah,
have to simplify my job. Then there is an option for us called storage class. Okay, till now we have seen storage class as a name assigned to that particular PV, so that your PVC can identify that particular PV, because every storage class, every PV which you create, you will assign some name so that your PVC will identify that particular PV. Okay, that is the intention actually. Why? Because every PV which is created will have a different storage. For example, let's say not all the PV will have the same storage backend which we are using, right? For some applications, I will use NFS as a
mm,
backend. For some applications, I will use host path. For some applications, I might use a different storage class. Sorry, different storage in the backend. So when my application is wanted to utilize a specific backend storage, I'll create that particular PV and I will ensure that that PV is utilized by that particular PVC. So this could happen only through storage class name. Now, even though if this
okay,
is done, but I have to create a PV as an administrator, right? To avoid this particular problem, we are creating this particular storage class for a dynamic PV creation. Okay,
okay,
so is that clear?
yeah, yeah,
Okay. So in the process of creating this dynamic PV creation, your NFS doesn't communicate and create this particular for you. We have to, and your storage class cannot talk to the backend storage, right? Storages it cannot talk. Okay, for that only we are taking the help of provisioner, which is like application running inside your Kubernetes cluster, which can talk to your NFS server in the backend. Okay, for your storage class. This is what it is happening right now. Okay, so once that is done, you can say it is successfully available right now, and we are trying to deploy MySQL. What we are trying to do, let's see from starting. So this is my service which I'm trying to expose my backend application. I'm trying to create only one replica, which means that if I don't specify any replicas, by default it will pick only one. Okay, and this is my password for my MySQL database to log in, test123, and I'm allowing all the hosts to communicate to my MySQL, and this is the port which is used. We already know it. Okay, and this is important for us. You are specifying your data related to your var lib MySQL should be stored in the NFS. So now we are trying to create a PVC. In that PVC, we specified read write once, and we have specified the storage size. Okay, let me try to decrease it actually. This is not that required. 5 is enough, 5 GB for now. Okay, so this is what I'm trying to request. Read write once and 5 GB as of now. Okay, which means that I know that only one replica will be running, right? So this is enough for me. Okay, so that is what I'm trying to do. And here the important thing is storage class name, NFS storage class. What is my storage class name? It is NFS storage class. Okay, this is what it is. Even though if you don't specify, it will utilize that. First, let's specify and see how it looks. After that, we will not specify and see whether it will pick that particular default PV and will storage class, and it will try to create a PV for you or not. Okay, so this is what I'm trying to do right now. So ultimately, I have to see my data related to varlib MySQL in the NFS server. Okay, but here we are not creating any PV. We are creating only PVC. Let's see that. kubectl get PV PVC. If you do have anything, nothing right now. And in your YAML file, let's cross verify. We have created only PVC section. That's it. There is no PV section. After this confirmation, let's try to spin up this application. Okay, it created all three resources. Let's verify. So kubectl get PV storage class. It's okay. You can see PV is created. You can see the name of the PV, persistent volume. What is the name? You can see here, right? Okay. Try to execute kubectl get all -c your application. Your MySQL application is running and your service is also created. Okay, let's try to verify login. First, let do this thing. MySQL -h IP -u root -p password is, oh, it is not installed. Okay, maybe. And these are new, this is a new cluster, right? Maybe I have not installed. Since I'm using MySQL, I'm using MySQL client only. If it is MariaDB, I would have used MariaDB. Okay. What is the password we have given in the YAML? Test123. I was able to log in. You can see here, show data bases. I logged in with my service cluster IP itself. Okay. So done. Successful, right? So come out. Let's create one database. Create database. Done. You can see. Let's come out of this. Okay. Now, what is the intention of this? What we are trying to do exactly? We are trying to understand whether the dynamic PV was created or not. It was created. Okay. You can see the naming conventions, how it is. The naming conventions of this is, you can see here, PVC was created, what we specified. Okay. And you can see this PVC and it got generated with a random number here. This is a random number. Okay, which is generated. You can see PVC hyphen some random number which is generated, and in the claim section you can see to which particular PVC it got attached. Okay, since this particular storage class is matching, it got created, and you can see what capacity you have specified in your YAML file and what access mode you have specified in the YAML file. With that only your PV was created. Your PV was created with that particular. You know that this reclaim policy will come from your storage class. Okay, you cannot modify this. If you want, you can do it, but yeah, we cannot do this right now. Okay, your application is running, everything is stored in the NFS server. What is our NFS? We are using the backend, NFS backend. Under this, whatever the name of your PV is, with that name, it will create a directory. But here the naming convention of this particular directory will be default is the namespace hyphen MySQL hyphen PV hyphen claim is nothing but your PVC name hyphen your PV name. That's how it is. Namespace hyphen PVC name hyphen PV name. That's how it is. With that, your directory will be created. and under that your data will get stored. You can see your voice
So
cut.
in the production scenario, like normal real cases, so you use dynamic
We
one
go
all the
like
time,
this.
or
We go like this. We go like this in productions. Okay.
okay, okay,
Yeah. This is the better option, right? See, intention is it depends. I told you some stateful set application, right? This MySQL and
mm,
some application, these are stateful applications, stateful set application, because stateful set in the sense they are the application is data is important. Okay, which means that it again if the pod is recreated, it has to create with the and it should get attached to the same PV which was used earlier.
yeah,
This will happen only in the stateful set applications. Okay, so there it
yeah,
will try to use the same PV which was used by earlier pod which got deleted. That's how it is. So no need to worry from your end as well. But most of the cases, stateful set applications will be used for databases and Elasticsearch in monitoring tool. These are data is important for them. Okay, where it is stored, it had to utilize the same data. For those kind of applications, we have to go for stateful set application. In those scenarios, this particular dynamic PV creation and all will help a lot. Okay, not only for
mm,
that, I gave you some example for all kind of applications. It is random generated. Okay, random generated. It knows how to handle it. Your Kubernetes knows how to handle it. Okay,
okay.
yeah. So now let's try to understand. Okay, what is this delete reclaim policy? You already know what is this read write once. You know the capacity and all. Delete in the sense what it does exactly. First of all, let us try to remove the application. We logged in everything we have seen, right? All the three databases we can see here. Our intention is to understand what is this exactly. Your StorageClass is working as per expectations or not. Now, if I try to delete my deployment first I will delete my service one by one. Okay, so kubectl delete my service. Okay, after that I will try to delete my deployment so that automatically it will delete my pod as well in the backend. So my application is getting deleted. Let's wait and see. So you can see it got cleaned up. Okay. After that, you know that PV/PVC will be available. That is the meaning of your persistent volume and persistent volume claim. Okay. Now, if I try to delete this particular PV, what will happen? It will delete your PVC. So what will happen to your data which is stored in NFS? Will it delete that particular data as well? Let's see. So kubectl delete. Okay. Let's try to remove this particular PVC. Okay. It got deleted. Now you see PV also got deleted. Why? Because the reclaim policy is deleted. Not only that, let's verify this one as well. Where is that? The path. You can see that also got deleted. Nothing is there under backup right now. It deleted that as well. Okay. So that is the meaning of deletion. Okay. So you have to be careful sometimes. Okay. Or else you have to change your reclaim policies to something like recycle or retain. Okay, but by default if you don't specify, it is a default reclaim policy for this particular StorageClass. Okay, whoever is using this particular what do you say this particular PV, they will get a delete reclaim policy, which means that if you delete your PVC as a user, if you try to delete it as an administrator, automatically it will delete this particular PV. Why? Because my reclaim policy is delete. Okay, so this is how it happens in the backend. Okay, so this is
Uh,
the entire
Sudhir, I have a question here.
yeah.
For this scenario, if I deleted only the deployment and I just create another deployment with the same file, then it will it automatically connect this PVC and PV, which is not deleted?
Of course, it will utilize that particular PVC, right? See, we are not doing anything with mapping of PV and PVC. We are utilizing the PVC to your new application. Okay, so that can be done. You can,
Okay. For example, I have two deployment and it will create two
okay, two
PVC.
different deployments. Okay,
Yeah,
okay,
two different deployment with the same application. and one I delete both of them, both deployment, and then I will create one deployment again.
Okay.
But the PVC and the PV are available. And which
Yes, yes, I
PVC will
understand.
automatically connect with the
Yes.
deployment?
So what you meant to say is nothing but the same PVC can be utilized by two deployments, let's say, two different deployments which you're trying to use actually. Yes, that can be utilized. But when it comes to the application, when it is trying to use the actual data, what will happen? Both are trying to open some particular file. In MySQL, you know that there is a locking actually, which means that file locking means if one application, one process has opened some particular file, another process cannot open the same file. It will get locked. Because of that, what will happen? One of the pod will go into a crash debug of error. Okay.
No, no. My question is, we have two deployment and two PVC and two PV.
Hmm.
And if I
Oh, two
delete,
PV PVC. Okay.
huh?
Okay. Understood. Understood. For another
And
deployment also, you are using a different PV and PVC. Okay.
yes, and if I delete both the deployment and I create one deployment, then which PVC will connect automatically?
What are the PVC you specify in your YAML? Simple. Yeah, you will specify your PVC name, right? See, that's what it is. See, you're not creating your application and it's directly getting attached, right? In your volume section, you're specifying which PVC you want to get attached
Okay, okay, yeah.
as application. See, PVC is
Hmm.
mandatory that should be created by your user. This PV creation is happened automatically by the administrator's capability of creating a storage class. That's what you have to understand. Okay, this is your request. What do you want? What size you want? What permissions you want? This is a request actually. That's the
And
reason the name is called as claim.
where we
Okay,
can define the retain policy of PV?
sorry.
If I want to define the reclaim
Yeah, yeah.
policy
Listen,
like
under this,
recycle.
under the spec, you will specify retain reclaim policy actually. So let me give one example here like this. In the PV, you'll specify it. But right now you're creating a storage class, right? So in the
Hmm.
storage class, you have to specify. Let's say, okay, so somewhere around here under provisioner or somewhere you can specify. Okay, your reclaim policy, or if you want to change other permissions or something, the default permissions and all, you can change it. Since I not specified anything for this storage class, the default provisioner, sorry, reclaim policy and the access modes are like that. Okay, that's how it is. And remember, the access mode depends upon what you are raising actually. Okay, as a user, I have said read write once, so that with the same permissions only, your PV will get created. Okay, but this reclaim policy is there, right? That depends on what you specify. By default, for this particular provisioner, it will take delete reclaim policy. Okay, if you want any other reclaim policy, explicitly you have to specify that. Okay, okay, yeah. Thank you. That's all for today. So tomorrow we'll come with another examples and let's see a different scenario apart from this. Okay?
Sudhir,
Yeah,
actually, I have a
yeah,
question.
yeah.
I
Go ahead.
have a I